Hello everyone and welcome back to Geminic Science. Let's assume we are given this kind of problem which says the coefficient of kinetic friction between block A and the table is given to us as 0.20, and we are given the mass of A to be 25 kg, then the mass of B as 15 kg. 25 kg, and here we are given 15 kg. We can choose to put it this way by writing our data, which the mass of A is simply going to be 25 kg, and the mass of B, that is block B, is going to be 15 kg. And here is the question: how far will the block B drop in the first 3 seconds after the system is released? So how can we solve this problem? Notice that the time which we are given is given to us as 3.0 in second, which is 3 seconds. And here we are given mu k, coefficient of kinetic friction, to be 0.20. So first thing which we need to do is to consider the net force by driving the system. And there are 3 things involved. First, we need to what? We need to identify the force which is pulling the system, and also identify the force that is the friction opposing the motion, and the total acceleration of the forces. So we're going to start by identifying the force pulling the system. And notice that this is going to be our F pull. And the second one, which is the friction opposing the motion, is going to be our F friction. Between A and B, which one is our F pull? Notice that the B block is the one which we are pulling upward, and this is going to be B. And the friction, which is going to be our A. Therefore, the equation is going to be F pull is simply going to be mg. Specifically, mb multiplied by g. Therefore, what is the value of our mb? mb is going to be 15. If you multiply 15 by 9.8, this is simply going to be 147.14 Newton, 4.15 rather. So for the next one, which is the friction force, which is going to be, let's put it as FF, which is going to be mu k, and we're going to multiply that by ma. Remember to put your gravity, which is 9.8. which is the same thing as saying 0.20. We're going to multiply with that by the value of A, which is 25, and we're going to multiply that by 9.8. And notice that if you multiply everything, it's simply going to be 49 Newton. So therefore, the 2 things which we are looking at, which is the F pull, were given to be 147.15 Newton. And here we're given the F friction, which is 49 Newton. So next thing we're going to be looking at is to find the total accelerating force, which we call the F net. And notice that this is going to be the F pull minus the F friction. In this case, what is the value of F pull? F pull are given as 147.15. But if you minus 49, which is the F friction from trying in Newton, which our answer is simply going to be 98.15 in Newton. So at this point, we can find the total mass. The total mass is going to be m total, which is going to be our ma plus our mb, which is the same thing as saying 25 plus 15, and the answer is simply going to be 40. To find the acceleration is going to be A, which is going to be F net, divided by our m total, which our F net is given as 98.15 divided by 40, and our acceleration is simply going to be 2.45 in meter per second squared. And this is our acceleration. But remember, from the question, what the thing which we need to focus is how far, which is the distance will block B drop? And this is where things get juicy. We're going to use this equation, which y is going to be a half at squared, which is the same thing as saying 1 divided by 2 multiplied by 2.45, which is in seconds squared, right? We're going to multiply that by our time, which is this. And your final answer should be somewhere around 11 in meters. So this is it for this problem. I hope you find it helpful. Please, if you do, just do me a favor by subscribing to Geminic Science. Thank you for watching. I see you next time. Hello everyone.